We're now in the famous crypt of Oxford Castle Quarter. It's at the base of the very tall Saxon Tower. It's very cold and it's very damp down here. And that gives us some problems with the stonework and the conservation, making sure that we're constantly looking after the great heritage around us.
We're in Worcester College Fellows Garden at the moment.
One of the things we're interested in particular with deteriorating stonework is the way that moisture goes into the stone and moves through the stone. And we can use various pieces of equipment to get an idea of how much moisture there is in the stone.
We're interested in moisture for several reasons, but one in particular is how it interacts with salt. Salt can lead to quite rapid decay and deterioration of stonework. We're just looking at some ivy growing on this stone wall, and this is an example of something that we're very interested in, how living organisms interact with stone. We've actually got very good evidence now that plants like ivy, which cover stone, can keep it dry to some extent, but also keep it warm in the winter, so that can reduce the risk of frost damage to materials like this.
Here we are on top of St George's Tower, arguably the best place to be in any castle, not least because you get to see those absolutely stunning views of Oxford. We are extremely high up, we're just under 100 feet tall, and so the sort of climate change at this level really has an effect on the stone. If you ever come up here, you'll see that the stone is in different stages of decay. It's also covered in lichen and different bacteria, which some people think it looks very pretty, and it doesn't really damage the stone in any way that we can tell until it gets very old. But also there's lots of challenges with rain and rainwater. So there are lots of things to consider all of the time when you're working in historic buildings like this.
Now let's look upwards even further. Mars has a very desert-like environment. We took some samples of rocks, which would be a bit like what you'd find on Mars, and then we create a little bit of Mars environment in here with carbon dioxide at low pressure, and we put it in some test facilities where we can control the temperature of this and go through Martian day to night temperature cycles, and then we measured the rocks to see if the strength within them had changed, to see if any sort of cracks had started appearing, the first signs of rock breakdown. And in fact, for some of them, it did. The Martian environment, the Martian extreme temperature changes appeared to make the rocks weaker. So this is a pathfinder for future experiments. We only just got the first hints of this kind of behaviour, but we hope to do more of this work in the future. My best rock jokes. A rock walked into a bar. I'm having a breakdown. So.